Hi everyone. So I am Lorraine Yu, a Physics SL student, IBDB student of St. Jude Catholic School. So this video is intended to teach about half-life. So I have here 10 problems and then which are all solvable. Yeah, and then another 10 problems which are multiple choice. So for our first problem here, iodine 131 has a half-life of 8 days. If the amount of iodine 131 in a sample is 8 grams, how much iodine 131 will remain after 32 days? So for this problem, we will be using the radioactive decay formula, which is A equals A sub 0 E to the power of KT, where K is equal to the to ln of 1/2 over the half-life, which is which can be expressed in years, days, numbers, seconds, minutes, depending on what's given in the problem. So for this problem, we are finding for how much iodine 131 will remain after 32 days. So for the original sample of the iodine, which is 8 grams, we will be putting that as the value for A sub 0, which is 8. So that's the original value of the amount of iodine 131 in the sample. And then E is a constant here, where E is equal to 2.71828. But in the calculator, you can just type E by pressing alpha, then this button here, X, okay, hold on, X, then X, so alpha and this button. So and then since it's an exponent K, so we substitute K here into ln of 1/2 over the half-life, which is 8 days. Then we multiply it with the total time, or like the total time, which is 32 days. And then when we solve that by using our calculator, or for the IB, it's actually the graphing calculator, but for physics, you can use this calculator. The answer will be 0.5 grams. So for number 2, we have here a piece of wood found in an ancient burial mound contains only half as much carbon-14 as a piece of wood cut from a living tree growing nearby. If the half-life for carbon-14 is 5,730 years, what is the approximate age of the ancient wood? So instead of using A, I used P for a change. So for my original amount for P sub 0, I have there 1G. So like the formula here is like the derivation of A equals A sub 0 EKT. So P of 5,730 equals 1/2 grams, because in the problem it says if the half-life for carbon-14 is 5,730 years, meaning we equate the 1/2 grams to P of 5,730. That's just for the sake of representation. And then after that, we then start the derivation. So I equated 1/2 equals 1 e to the exponent of 5,730k. Okay? And then after that, I use the ln rule, the natural logarithm rule. So this is like based in algebra. This I based it on I based my solutions on algebra, not through calculus, but I think you can also solve them through calculus. So if we use algebra, we have here ln of 1/2 equals ln of e, then 5,730k. This time, the exponent will not be an exponent anymore. And then after that, we cancel out the redundant numbers like 5,730. And then, yung ln of e, we cancel ln of e since ln of e can be equal to 1, or is always equal to 1. Anyway, so if we use the calculator, we solve ln of 1/2. So like there's an ln number here. There you go, that one. And then over 5,730. Through dividing that with the use of the calculator, that's equal, k is equal to negative 0.0001297, or 1.2097 times 10 to the negative 4 power, depending on what you desire to use. But I think it's easier if you round it off. And yeah. So after that, once again, we solve through another derived equation from the original equation. So p sub 0 times t equals p times e to the exponent of our k. So p sub 0 is 1 gram. This one, which is the same as this one. Anyway, so p times t, p of t equals 0.5 grams. So that's like 0.5 equals 1 e to the exponent of negative 0.0001297. So once again, we use this digit, this one, which is ln of e, which equates to 1, like from here. So yeah. So ln of e, negative exponent negative 0.0001297. Then in the other side, we also use the natural logarithm rule. So there's ln of 0.5. So after that, we solve already. ln of 0.5 equals negative 0.0001297 t times ln of e. So in this part, we cancel out the ln of e since it's just equal to 1. Then we cancel this one. We cancel this one since we have that as a denominator as well. And then after that, we just have to divide ln of 0.5 over negative 0.0001297. And that is equal to 5,730 years. But if you notice, it's just the same, 5,730 years and 5,730 years. But for time's sake, for further explanations, you can just chat me on Facebook, and I have the manual way of solving that here in my scratch paper. It's in a table form, the elementary way, the grade 6 way, but anyway, yeah. So for our third question, the isotope Pb-210 has a half-life of 22 years. What percentage of a pure Pb-210 sample prepared in April 1937 remains in April 2003? So, to calculate the total number of years, first we find out the total number of years, which in this case, it's 66. How did I get 66? I just subtracted 2003 to 1957, and the answer is 66. So, okay, since our half-life here is 22 years, and then we're finding for the percentage. So to find the percentage, which is A in this case, I represented it with A equals the total percentage divided by 1/2 to the power of 3. So anyway, to solve that, first we have to find n. N is the number of half-lives. Okay, number of half-lives, not half-life. There's like a difference between the definitions of both phrases. Anyway, so the equation for n goes this way. N equals total time over half-life. So we just substitute. I don't think I should explain substitution to you since you've learned that in elementary and high school. So n equals 66 over 22, and that's n equals 3. And then after that, this is like a multiple multi-step problem. After that, we then equate that to a equals 100 over 2 exponent 3. Why is it 100? Now, if you solve that manually, the percentage is like 100 first, 150 for the half-life, then 25, and then 12.5, etc., etc. Anyway, I also have the manual way of solving this, the grade 6 way. You can message me on Facebook for that, or email me through my St. Jude email account. Anyway, so 100 over 2 to the exponent of n. 2 to the exponent of 3. So why is it like this? Once again, a is equal to the total percentage divided by 1/2 to the power of 3. So like 1/2, or also known as 1/2, 100 times 1 over 8. So like that's equal to 25 over 2, or since we have to express that in percentage form, that's 12.5% here in the calculator. But yeah, you can do it by yourself also in the calculator to check. Anyway, so okay, so for our next problem, the half-life of Protactinium-234 is 6.75 hours. How much or what fraction of a given amount remains after 27.0 hours? So, n equals total time over half-life. We use this equation again, like what we used in number 3. So, our total time here is 27 hours, right? And then we divide that to the half-life, which is 6.75 hours. And through our calculator, we get n equals 4. And then, since this is a multi-step problem, we use this equation, a equals 100 over 2 exponent n. So 100 here, we used 100 here, just as how I explained it in the previous number. So we used 100 here, since 100 in percentage, 100 is the like highest amount for percentage. So like 150, blah blah, 25, 12.5, etc., etc. I have that in table form here, which once again, you can message me on Facebook for the elementary version anyway. So, a equals 100 over 2 to the exponent of 4. So, 2 to the exponent of 4 is equal 16. So, in other words, that's 100 over 16. So, 100 over 16 is equal to 6.25%. But since this problem asks for what fraction, we convert that into decimal, and then after we convert that into decimal, we can now solve for the fraction, and we get this. Oh my gosh, yep, that's 25 over 4. So our answer for this number is 25 over 4. Now, moving on to the next problem. The half-life of plutonium-239 is 24,100 years. Of an original mass of 100 grams, how much in grams will remain after 96,400 years? So we use the original equation. A sub 0 equals a sub a sub 0 1/2 exponent n anyway. So like n once again equals total time over half-life, like what I used here. So n equals 96,400, which is the total time, over 24,100 years, which is the half-life. And then we get the answer 4. So, to solve for the mass in grams, we use we use the mass number of plutonium, so like that's like 11 over 2 exponent 4. So it's supposed to be 100, by the way. So anyway, 100 over 2 exponent 4. This is supposed to be 100, guys. Sorry for confusing you. Anyway, m equals 100 over 16, we get 6.25 grams. Basically, the way I solved this one is just the same as the previous number, except that the difference is this one's like in percentage or in fraction, and this one here is like in grams. Anyway, so for the next number, 6. What is the half-life of an element if a 500 gram sample decays to 62.5 grams in 639,000 years? So, A equals A sub 0 E exponent KT. So, 62.5 equals 500 E exponent ln 1/2 over x times 639,000 over 500 here and then 500 here. So like I basically just canceled out this one here and this one here so that it gets transposed to this side of the equation or of the solution, so that it will be easier for us to solve. And so 62.5 over 500 is 0.125. Then that's going to be equal to E exponent ln of 1/2 over x times 639,000. So to erase E here, and for it to be easier for us to solve, we use the rule for the natural logarithm, which is using ln times 0.125 equals ln of E exponent ln 1/2 over x times 639,000. So once again, for it to be easier for us to solve, we cancel ln of E, since ln of E is equal to 1. And then we solve it through this one. Or if not, we can solve like E to the exponent of ln of 1/2 over x times 639,000, and we get this one. But I think it's going to be easier for us if we cancel this. If we cancel ln of E. So, ln of 0.125 is equal to negative 2.079441542. Then we multiply it with x. Then we equate it to the entire value of this one. So we solve that through the calculator, and the entire value for this one is negative 442921.0484, and that equates to this. So like over negative 2.079441542, so divided by 2.079441542 as well in the other side, and we get x equals 213,000 years. I hope we got the same answer, but if your solution's correct, then my bad. But if your solution's wrong, then I think mine's correct. But anyway, moving on to the next number. I think I spoke a lot. So moving on to the next number, how long will it take for 16 grams of Ra226 to break down until only 1.0 grams remain? By the way, if you solve for half-life, you may at times also need your periodic table of elements. This is physics class, but you also have to relate physics to chemistry. I just knew that 2 weeks ago, but anyway, we start solving this problem. So the half-life of Ra226 is 1,600 years, according to Google. Anyway, so we use this equation, A equals A sub 0, E exponent KT. So 1 equals, so we just substitute again, 1 equals 16e to the exponent of ln of 1/2 over 1,600 times t. Then we divide that to 16. So 1 over 16 equals e to the exponent of ln of 1/2 over 1,600 t. So 1 over 16 is 0.0625, which is equal to ln of e. By the way, you can start using the natural logarithm rule once again. So ln of e times ln of 1/2 over 1,600 t. So ln times 0.0625 equals ln of 1/2 over 1,600 times t. So ln of 0.0625 is equal to negative 2.7725888722 equals, we solve for ln of 1/2 over 1,600, which is equal to negative 4.3321698878 times 10 to the negative 4th power. Then we multiply it to t, and then we cancel out negative 4.3321698878 times 10 to the negative fourth power in both sides of the solution or of the equation, and we get t equals 6,400 years by dividing negative 2.772588,722 to negative 4.332169,878 times 10 to the negative fourth power. Okay, so for our next number, we have here the nuclear reactions. Anyway, so give the reaction for the alpha emissions of polonium-210. So polonium has this mass number and then atomic number, or like the proton, so 210 then 84. But since it's like an alpha decay or an alpha emission, we use this alpha then like 4 and then 2 there. That's like fixed, guys. That's fixed. There's also like values for positron electron emission for that, and then there's also values for beta decay for that. But since this problem's like asking for alpha emission, we use this. Okay, you may encounter this a lot of times, and yeah, you just have to know that this is like fixed, so it's gonna be easier for you to solve. Then through the periodic table of elements, we use the periodic table of elements to find this one. So that's like so easy. So 210 minus 4 equals 206, and then 84 minus 2 is 82. So yeah, as simple as that, guys. And for this next one here, give the reaction for the beta decay of carbon-14. So the carbon-14, this one's like the mass number, and this one's the atomic number. So carbon-14, then 6. So that's how it's always gonna be like used, or like placed, or like written. And then like since it's like a beta decay or beta emission, we use the beta sign, then 0, negative 1. So this is like, once again, this is like fixed. And then to get this one here, by the way, you get to know like the PB or like the N here after you like solve for like 14 minus 0 equals 14, and then like here is like 6 minus negative 1 is like 7, and then I knew it was N because like in the periodic table of elements, the atomic number of N is 7, so like that's how you know it, like you just know it. Anyway, so like this is the answer for the reaction for this like item. Anyway, for number 9, a sample of a radioisotope is found to have decreased from 47 grams to 2.94 grams in 3.3 days. Calculate the half-life. So we once again use the original equation, and then we can, which is like a equals a sub 0 e exponent kt, and then we substitute, so it becomes 2.94 equals 47 e exponent ln 1/2 over x times 3.3, and then for it to be easier to solve, we divide or transpose both sides with like 47, so we cancel this out in this side of the equation, and this side we like divide 2.94 to 47, and we get like 0.06255319149 equals e to the exponent of ln of 1/2 over x times 3.3. And after that we solve it with through the use of ln, the natural logarithm rule. So there's like ln of 0.06255319149 equals ln of e times ln of 1/2 over x times 3.3. So this time this is not anymore like an exponent. So anyway, after that, since ln of e equals 1, we basically just copy this here, and then we like cancel this out, and then copy this here. And after that we solve for it. So negative 2.77173802 02, then x, or like whatever. Yeah, like x, because of this one. And like the negative 2.77 blah 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 there came from ln of 0.06255319149. And after that, L of 1/2 over x times 3.3 blah blah blah. We just cancel this out because this is redundant here already. And then like the answer for that, so once again we like transpose and then cancel out the redundant stuff. And like x, ln of 1/2 times 3.3 is like negative 2.287385696. So we cancel this out and then divide this number here, and we get 0.82 days. So for the last number, we have a sample of radioisotope is found to have decreased from 11 grams to 0.0859 grams in 1.23 minutes. So in this problem, we have to calculate the half-life, which I represented as x in my solution. So to solve for that, I just substituted again the numbers in the equation a equals a sub 0 e exponent kt. So 0.0859 equals 11e exponent ln of 1/2 over x times 1.23. Now, since k is ln of 1/2 over the half-life, so that's why it became like this. And once again I represented the half-life as x. So I cancelled out 11 for it to be easier to solve, and then in this part I just divide 0.0859 to 11, and the answer is 7.81 times 10 to the negative 3 power equals e exponent ln of 1/2 over x times 1.23. So through the natural logarithm rule, I then solved for ln of 7.81 times 10 to the negative 3. Then I equated it to ln of e exponent ln of 1/2 over x times 1.23. And then since ln of e is equal to 1, the exponent became like this. And then in this part of the equation, I solved through the calculator, and then the answer is negative 4.852350315. Then that is equal to ln of 1/2 over x times 1.23. And then in this part, so I transposed, cross-multiplied, so it became negative 4.852350315x equals ln of 1/2 times 1.23. And then the answer for this is negative 0.8525710.321. And then I divide both sides with negative 4.852350315, and the answer for this number is the half-life is 0.18 minutes. Next, we have this. So, when an alpha particle collides with a nucleus of nitrogen-14, represented as this with an atomic number of 7, a nucleus X can be produced together with a proton. What is X? So that is for next number. So what I did is X, 14, then 7, right? Then I added it to the alpha particle, which is like the alpha sign, then 4 on the upper part, and then 2 on the lower part. And then the answer for that is 18 and 9. So that's why this is the answer. Letter C. Next, which of the following lists 3 fundamental forces in increasing order of strength? So, number 2, my answer is gravity, then weak nuclear, then electromagnetic. Okay, so gravity is a scientific term which refers to all things with mass brought towards one another. And then weak nuclear is the weak nuclear force is stronger than the force of gravity, but effective only at short distances. But however, it plays a great role in things when they fall apart. So it's just like more or less the same as gravity, but stronger than gravity. Next is the electromagnetic force, which is like a type of interaction or a type of force that involves electrically charged particles. So that's why my answer is letter C. And then electromagnetic force is stronger than gravity and weak nuclear. So that's why my answer is letter C. Next, what is the relationship between nuclear number A, proton number Z, and neutron number N? Now, so it's normally A equals NZ because like a nucleon number is equal to the total number of nucleons in the nucleus of an atom. But since we can't find A equals N plus Z here, we can find A equals N plus Z. So what I did is I equated N to A and Z, and this is the answer. So N equals A minus Z. Okay, so that's why this is my answer, letter C. Number 4. The initial number of atoms in a pure radioactive sample is N. The radioactive half-life of the sample is defined as, the answer is C, the time taken for N over 2 atoms to undergo decay. Since half-life is defined as the time it takes for 1/2 of the atoms of a radioactive material to disintegrate. So that's why the answer is C. So for the next number, some of the energy levels for a hydrogen atom are shown in the diagram. So this is the diagram. I hope you can see that. And then this is the table which shows the 4 photons with their corresponding energies. So W, then 8.6, then X, then 10.2, then Y, then 12.1, then Z, then 12.6. So each photon is incident on a hydrogen atom in its ground state, which photons can be absorbed by the atom. So my answer here is X and Y only, since what I did is like 12.6, I mean like, since what I did here is like 13.6 minus like 3.4. So yeah. And then on the other hand, for the 12.1 is like 13.6 minus 1.5. So if you ask me where I got 13.6, it's just, anyway, yeah, so that's basically how I got that. And then for number, that's why my answer is like X and Y only. So for number 6, which of the following provides evidence for the existence of atomic energy levels? It's radioactive decay, because absorption spectra is defined as a spectrum of electromagnetic radiation transmitted through a substance. Next, for nuclear fission, the definition is a nuclear reaction in which a heavy nucleus splits spontaneously with another particle with energy release where its positive charge with energy release. So for the Geiger-Marsden experiment, the definition is that scientists discovered that every atom contains a nucleus where its positive charge and mass are concentrated. Then, like for radioactive decay, it's defined as a process where an unstable atomic nucleus loses energy by emitting radiation. So that's why radioactive decay provides evidence for the existence of atomic energy levels, because of the unstable atomic nucleus that loses energy when they emit radiation. So for number 7, a radioactive sample has activity A sub 0 at T equals 0. What will be the activity of the sample after 2 half-lives? So that's basically 1/2, then another 1/2. So that's why the answer is like 1/4. And that's why it's like A sub 0 equals 4. That's why my answer is B. A sub 0 over 4. That's why my answer is B. Next, in a neutral atom, there are n electrons, n sub e electrons, n sub p protons, and n sub n neutrons. What is the mass number of the nuclide? So for this number, n sub p is represented as the atomic number. Then, since we don't have n sub p here, then I mean, like, there's yeah, I mean, yeah. And then n sub n is the neutron number. N sub p can be the atomic number and can also be the proton, since in the periodic table of elements, the number of protons is equal to the value of the atomic number. Now, since like mass number A equals n sub n plus n sub p, since mass number is the sum of the protons and neutrons, that's why my answer is B for this number. Next, number 9, the student suggests the following nuclear reaction between deuterium and tritium, where n and m are integers. What are x and y? So for this number, the answer is letter C. Because, remember, an alpha particle is has like 4 on top, then 2 down there. Then we add that with neutron, which has like 1 on top, then 0 down here. So, since H, this one has like the value of like H, then 5 on top and 2 below. If we add the alpha particle and the neutron, it also has like 5 on top and then 2 below. So like they basically equate with each other already. That's why the answer here is alpha particle and neutron, so that both are balanced. Both sides of this one are balanced. Next, number 10. Nuclei of the isotope nitrogen-14 are bombarded with neutrons, and as a result, nuclei of an isotope of carbon are produced. The nuclear reaction equation for this process may be written as 14(7n) plus neutron, which has like 1 charge on top and 0 charge down, neutron, then it like basically equates to like the C, then A on top, 6 below, plus the proton. So, for proton, it has like 0 on top, then 1 below. So the C, the value for C here, I mean for like A in this equation, for A, the value for A in this equation is 15. Kasi because if you minus like 14 plus 1 equals 15, minus the 0 here, so that's equal to 15, right? So that's why A equals 15, and so my answer is letter D. Now for 7, then 7 for the value here down, it's just like 7 minus the 1 here. That's why it's 6 here, and then it's 0 here. So that's why my answer is D. Okay.